What? Show of hands. How many of you guys have seen a hack? Taking place? That cat. You probably did it because you were the first one to raise your hand. So you were probably the guy. One of the things that we see in hacks is it's not really a proper term for what happens when there's an intrusion. I will say that there are some times that we're looking at perhaps poorly written code. We're perhaps looking at inadvertently somebody brings a dirty device inside, or there's plain Jane, somebody that comes with malicious intent from the inside. So we know the MITRE framework. We know what we're looking at. Engage in this part of the cyber kill chain. But one of the things that the deception technologies allow us to do is how do we deal with the insider threat? Even on the outside, because frankly, in the years that I've been doing this, I've seen external attacks or external hacks about 3-4 times in my entire career. And they were mostly done in the government, so that was a different story. Anyway, but what the deception technologies relative to the MITRE framework attempt to do is to create a decoy. And a decoy that me, as a Mr. Bad Guy, gonna see it, and it's gonna show perhaps as a fully unprotected PLC. And I'm going to go after that PLC, and I'll give you one of the ways that we used to address security issues in the government. As a matter of fact, and most hackers, the way that they go about finding their targets is that they create a fire, what we call a trash can fire, and a trash can fire is nothing but I'm going to go and create and do one action that is going to force you to react outside of the boundaries of what you're used to doing. So at that point, you go, let's say for instance that we try to compromise an NT server or a Windows server of whatever AD or something of that nature, and you run. I'm looking at what you're going to do. And based on that, I will design the real attack. Well, I'm sorry, they will design the real attack. Now, if you come up with a lure that will take me to that place, and I will go after that device, and then that device will communicate efficiently with the rest of my security infrastructure, well, I'm probably going to look like a dumbass. That's what we're trying to do. That's what deception technologies do, is lure the attacker into a position that it can be mitigated. And it can create a fast response. Let's not call it automated, because again, automation can be a 4-letter word still. Why do we recommend deception? It reduces the risk. Frankly, I know on the tactical side, yeah, it's fast response, but on the strategic side of deception technologies, we're looking at, they are future-proofing our network. We're future-proofing our investment, because again, let's go back to square number one when we were talking about time. Time is money. We are looking here that by all this automation, all this concerted effort of all these technologies that we have together is going to reduce the time to response. If it reduces the time to response, you don't have to deal with forensics, you don't have to deal with all that stuff, which means that you'll become a more efficient operation. And in our business, that efficiency can be directly translated to safety and efficiency. Safety, well, I don't have to tell you guys what safety does for our business. And of course, efficiency, because we want to get the most of our FTEs. So here we go. Adding deception technologies. Again, I'm not going to say that this is the North Star. However, it's a really good technology to include, because frankly, most of the attackers, they don't expect to see this. How do we correlate all this stuff? Security information and event management. We have a gazillion sources of data, and going back to the alert fatigue, I don't know and I don't care. That's what we're trying to avoid. We're trying to avoid I don't know and I don't care. So we're going to take that information and we're going to put it in a way that it can be first based on that MITRE attack framework, but also that we can correlate it and add all those sources of information in a way that it can be expressed in meaningful dashboards that go back and correlate to the SOAR or the response dashboards. Now, when we start, and I'm sorry, I'm running out of time, so I'm going really fast on this. When we're looking at in terms of what we do, we talk about that framework, the IC 62443 and the Purdue model. If we can present those alarms and those conditions in a way that correlates to that model that is tiered from the operation all the way down to the in between IT and OT, we're saving ourselves a lot of time. It makes it a lot more efficient. Anyway, all right. Thank you for your time, guys. I think that we are on time here. Any questions so far? Mr. Blavel, will you please come on up?
Yeah, any questions? Yeah.
So, I don't know how to ask this question. Since you mentioned defense in depth, my question is, how feasible is it to air gap all the critical systems, bring them online on demand, do the backup, software updates, and then air gap them again?
That seems, that seems enormously complex. You know, I know we do that in certain industries. Nuclear power comes to mind. When we're doing updates, maybe we, sneaker net updates across that air gap. I think that's why generally we don't find air gaps in industry at this point. It can be done. It's a lot to manage. Certainly important to mind your maintenance windows, whatever those may be, and also equally important to ensure that that air gap, once reestablished, stays established. That gets into your visibility, right? Can if I start seeing Modbus occur between two links that I'm not used to, or some other thing that I have identified as a Rockwell Automation PLC, that's a pretty good indication that my air gap was not kept, right? And so if you're going to do that, I'd say the benefits aren't really great to doing that, but if you are going to do that, make sure you're monitoring your network to make sure that your air gap actually is.
If you guys want to break the air gap, or you want you want to test your air gap, if you think that is, we used to call it security by obscurity, but that line is disappearing. It's becoming kind of shady. If you want to test your air gap, block Instagram and Facebook and all the social media, and you're going to see if you're really air gap or not, because somebody's going to figure out a way to jump across. And that's one of the things that going back to visibility, because what we're looking at is, we want to preserve. I know for some businesses that they need to be air gap, need to be separated because they're regulated. However, for us, it's constant security posture assessment. And in there, and I can tell you from my own experience that I have seen that where we block everything and all of a sudden you see somebody trying to get into Instagram. So there is constant assessment, security assessment, consistent. Any other questions? Are there still lunch out there? Any hungry?
If I can just add something, oh yeah, please go ahead.
So you were describing a PLC or system that everybody's going to go as a priority to. Is it like a honeypot or something?
The deception, yeah. So what is
my question is, how do you make it look to the hacker that it's important?
How do you make it not look like a honeypot? Yeah, no, that's a really important question. Let's get into what the difference is, though, first. Deception and honeypot. So the honeypot is the device that's sitting out there, right? The difference between deception and honeypots is the lures, right? Having those lures that are out there. And so we talked about the PLC example. We've had some customers that actually integrate the deceptor into their SCADA system. So their SCADA system is pulling it for data. That's how you make it look important. We also have some honeypots that are a Windows XP machine, right? You're probably going to find those on a manufacturing floor or power generation, water, whatever you have, right? You put credentials onto an engineer's machine for that Windows XP machine. Those engineers get compromised. they try to use those credentials, you know you have a problem, right? And the point of all of this is that it's extremely low false positive, right? We're talking about that fidelity of data and the confidence of the data. Maybe you have a SCADA engineer that's about to have a really bad day, but more than likely you have an adversary in your network that's poking around. And so that's how we move ourselves back to the left on that MITRE attack framework, right? Integrate it with your systems. Put credentials out there for people to find. Place these things out there for people to find whether or not they're doing a massive scam. Yeah.
I know I'm between you and your lunch, so please bear with me for a second. You had an example where you showed a SCADA system and then the interaction from the SCADA system to various PLCs and how you provide that level of security so that you know exactly who is talking, or you can identify yourself. But beyond that system, right? I mean, if you look at factory networks, it's not just the SCADA, it's your different databases, it's also the cloud. So how do you make sure that from an end-to-end perspective, you have that same level of security, right? Outside of the example that you provided.
Really good question, and I'm glad that you brought the four-letter word cloud. It used to be that our compute was limited to a data center, and now we know, I mean, again, to what Chris said, resiliency, redundancy, all those factors come into place. So the deal, I mean, to us, is having a uniform operating system and security posture that is the same on a physical appliance, private cloud, and public cloud. And at that point, you can design a system that is the same, and the user experience remains the same. Because honestly, at the end, if they don't know that they're running on the cloud, they're running on the cloud, right? However, what is our responsibility to make it secure, make it efficient, make it safe? I guess, and 80% of the time, I mean, definitely, I mean, going back to the lures and deception technologies and all that, I mean, if we can translate that and take it in, I mean, basically make it ubiquitous, that nobody knows where they're at, make it redundant, it's really important. And about 75% of the time, statistics are made up on the spot, so I made up that deal, that 80%, so that's okay. But no, all joke aside, it is the fact that having a operating system, a system that all the security components, I mean, look the same in the physical plane as they do in the virtual plane, that is really important.
Okay.
Bueller.
Are we wrapped up now, or we have any more questions, or? He's one of us. Oh, okay. All right. So are there any more questions? Okay.
Yeah.
Fortinet team, thank you very much. Great job.